Hello. Today I'm going to go over Topic 1, Section 8 of Equations and Systems of Equations. So first let's talk about polynomial equations. You need to be able to identify them and correctly name them. So the first one is a degree of 0 and a constant line. Okay, what this means is your example. Look at our example over here, p of x. That's a fancy way of saying y. So we've got y equals 3. We know that is a horizontal line, right? That is constant. It's never changing, okay? Hence constant, okay? It's the general form is just p of x equals a, where a is some number, okay? The degree comes from, well, the variable, and you'll see once we insert it in the next one, because the next one is linear. So here we've got ax plus b. So here y equals mx plus b. Gotta actually write my x, that might help. Mx plus b, think of it like that. So you have a line. All right, so that's when you start changing your y. All right, now you have an x, so your degree is 1, because that's x to the first power. Technically, we can write this one with variable x. We can write it as a times x to the 0, right? Anything to the 0 power is 1. So it simplifies to a. So the degree is the exponent of the variable, the highest exponent. So the next one would be your quadratic. So your ax squared plus bx plus c. So whenever you see an x squared, it's a quadratic. And cubic is x cubed. Quartic is x to the 4th. Quintic is x to the 5th. I mean, you keep going, but nobody really goes up that high. Okay, these are your basic ones. All right, these are the ones we manipulate. All right, so let's do an example. First thing is we need to know the fundamental theorem of algebra, which states that when we have the highest degree is n, see these are all less than n, all right, when the highest exponent of the variable is n, we will have no more than n roots. So for here, for p of x, this highest degree is x cubed, okay, x cubed. So that means I should have no more than 3 solutions. Sorry, pressing all the wrong buttons. Okay, so this will have no more than 3 solutions. All right, according to that. All right, so here we want to determine whether any of these values are roots of that polynomial. So what makes it a root or a solution or a 0? Okay, if I were to graph it, all right, think about if I had, let's do something simple like y. Oops. So, you know, if I just had any old quadratic, so like 2x squared plus x plus 5, right? If I can't factor it, then I can use the quadratic formula, and all that finds your roots, so where it is on the x axis. Ooh, my curve messed up there. So that's what we're looking for, the zeros, the roots, the solutions. They're all where it hits the x-axis. So if the roots represent my x's, then the y's going to be 0, right? All these points, this would be like x comma 0. This one would be some other negative number comma 0, right? So we plug them in. So let's do p of 3. We do 3 cubed minus 2, 3 squared minus 5 times 3 plus 6. I would just plug it into my calculator, personally. So 3 cubed over minus 2 times 3 squared minus 5 times 3 plus 6. Alright, so I get 0. So that is a solution. Okay, so we try 2.5. So plug in 2.5. So do 2.5 cubed minus 2 times 2.5 squared minus 5 times 2.5 plus 6. Plug it into your calculator. See, you should get negative 3.375. So that's not a solution. Plug in p of negative 2. When you plug that into your equation, just like you did the rest of these, you get 0. So that is a solution. Plug in p of 5. You get 56. That's not a solution. So here we have two solutions, 3 and negative 2, but we have probably another one out there, right? Because this has 3 solutions, okay? Or one of those could be repeated, we don't know, okay? But that's how we can tell if it is a solution. So again, how do we find those solutions? I can plug it into my handy dandy calculator. You can do it one of 2 ways. Actually, there's 3 ways, so bear with me. We can go to our apps, our poly simulation. Okay, this one has highest degree is 3. Next, we enter the coefficients, 1, 1, 1, 1, and we solve. We get negative 1 is a real root. Okay, so what's another way if I don't have that on my calculator? Okay, I exit out of this. Then I can graph it. So I can plug in, let's see, x cubed plus x squared plus x plus 1. When we graph it, we then look for our x-intercept. So we can second trace it. We find the 0, and you just follow the commands. All right, it asks for the right bound. Uh-oh, I think it already started this one. I must have accidentally hit a button twice, because you're supposed to start with the left bound. Okay, left bound, right bound, there we go. At negative 1, y is 0. Okay, and let's see. So there's one more way. We can go to math, go down or up, all the way to the bottom of solver. Enter, in this way, the TI-84, we enter both sides of the equation. So the left side of the equation is 0, and we go down to the right side of the equation and we type in x cubed plus x squared plus x plus 1. We hit OK, and then there we have x is negative 1. Okay, so again, there's 3 different ways to solve these equations. Okay, and remember that you're looking for at most 3 values. Okay, so why don't you try the next ones on your calculator, see what you get. Be sure to pause it. Here we go. Trash can's over there. Okay, so sometimes, of course, you'll get decimals, right? And that's perfectly fine. Okay, so now we're going to do systems of linear equations. So yes, you could do the algebraic way and do substitution or elimination, okay? Or we could go the easy way, all right? The IB test is only expecting you to do this with your calculator. They do not expect you to do this by hand. So let's do it with our calculator. So you get out your calculator, you can second mode, which quits it, right? Anything that you're in. So then I just clear it because I don't know, OCD. So then we go to apps, go to poly simulation. Here you're going to want that. I'm telling you, you guys, you're really going to want to invest in a graphing calculator because it's going to do all these little features for you. Okay, and be sure to update it. Okay, you can update those calculators. All right, so for this one, we can go down to our simultaneous equation solver, so number 2, because now we have more than one equation. So here we have 2 equations with 2 unknowns, right? 2 equations with 2 variables. And I'd like my answer as a fraction, because that's usually easier, and I keep everything else the same. So we have to write it as a matrix, okay? The matrix is your coefficient of these equals your constant. So here, our first matrix would be 2, 3, -1, 4. And our second matrix is going to be 10 and -5. So back to the calculator. So we hit 2, 3. Let's see, 10, it's going straight across. That's nice. -1, 4, -5. So you can do one equation at a time. That's what it looks like. Okay, so you got this left side and that right side. Then you hit solve. You should get 5 and 0. Check your answer. 5 and 0. Perfect. Let's try this one. Get a second quit. Let's see, go back, hit enter because we're on number 2. Now we're going to have 3 equations. Make sure that's highlighted by hitting enter. Then go to 3 unknowns because now we have x, y, and z. And hit next. Now again, it's very important that you hit them in order. So you do your x, your y, z, then your constant. X, y, z equals your constant. So you have -2, 1, -1, and 3 for the first line. The second line is going to be 1, 4, and then since we don't have a z, we need a placeholder, so we put 0, because the 0 times z would just disappear, equals -2. Then we get 3, 2, 5, 0. Then hit solve. And here we get these answers. All right, so we get a fraction. Let's see, how did they write it? They did it as sig figs. Okay, let's go back. So let's see, mode, go down, hit decimal, then hit next. Make sure it saved it good. Yes. So here, yep, -2.11, yep, 0.0286, and 1.26, because you're doing 3 significant figures. There you have it. So use that calculator. There are a couple different solutions that can happen. You can have it intersect at a point. So here you actually get a solution. Here, the second one was where they do not intersect at all, and so that's when your calculator screams at you, no solution. Okay, and that would mean that your lines would be parallel. Okay, so they're never going to intersect. Right, the first one would be more like having one line do this and another line doing that. something else. And then the last one, all right, what would happen there is if you have a line and the second one is actually right on top of it. So every single point on the line matches. And when you do this one on your calculator, right, if you don't notice that they're the same line right away, maybe you just plug it right in, your solution set comes out really weird, right? You get 1.3333 plus 0.6 repeating times x2, where x2 equals x2. Totally weird. Makes no sense, okay? That's the same solution, right? Your calculator kind of just spazzes out. Okay, so in topic 2, section 6, they do the introduction to modeling skills. So where we use systems and equations to model real-world examples, okay? So again, just to recap the solving part in topic 1, we can set, well here we can solve this equation. We can set the whole thing equal to 0, meaning, here, let me write it all out. So for this one, we literally move everything over to the other side. So we get 0 equals negative x cubed plus 2x minus 1 plus e to the 2x minus 1. We plug that into our calculator. So we graph this. Okay, and then find your x-intercepts. For the second one, we can graph the equation of the left side. So you graph this side and you graph this side. So your first equation would be x cubed minus 2x plus 1, and your second equation would be e to the 2x minus 1. You graph those, find their intersection. All right? Okay, so I probably wouldn't use the numeric solver here just because there's got so many variables of x. Trying to solve it would be difficult. I would use a numeric solver when it's a little bit more basic. Okay, so here I would graph it. So when you graph it, you should get something like this. You find your intersection and your points. Your answer would be negative 1.77 and 0.22, because that's your x values of the intersection. So now, of course, you want to apply it to a word problem. So here, we want to find how much time has passed. So we want to be solving for t. So then n of t, so it's got to equal 2,000. So here you can either solve it by hand or use your numeric solver, set it equal to 0 and find the x-intercepts. I mean, lots of different options. I would utilize your calculator, okay? So that way you're less likely to make a mistake, okay? So here you'll end up with x equals 3.32. So just tell me what you did to get what you did on your calculator. So here we have a another word problem where we're plugging stuff in. We know that it's going to fit into this function. This is our equation, and these points are solutions. So I need to be able to plug those in. So when I plug in, let's see, 1 and 0, sorry. Okay, so we would you would do a times 1 squared plus b times 1 plus c, and that would equal my output, which was y, which is 0. Then you do 2 and 9, plug in 2, a times 2 squared plus b times 2, that's 2, right, plus c equals 9. Then you have your third one. Okay, you're going to have a times negative 2 squared plus b times negative 2 plus c equals negative 3. All right, so now once you simplify those, you get 3 systems, 3 equations. plug that into your calculator, and there you have it. Okay, so utilize that option. Okay. All right, let me know if you have any questions. I'll see you in class.